And here we go. Today we're going to talk about the next assignment, which is assignment C, and it's on gravitational force. Now, you guys actually have a sim on this as well. So what we're looking at is how things get attracted to each other, and the question we have here is make sure you know scientific notation because we've got everything that's in scientific notation. The Sun has a mass of 2.0 times 10 to the 30th. That's heavy, dudes. And then we got a radius of 7.0 times 10 to the 5th. So what we're having here is, whoops, change that to my pen. Let's go. I would say magenta, but everybody's saying purple, but we'll go with that then. So basically we have our Sun. And the radius of this dude is 7 times 10 to the 5th. Now what we have is that we have on the surface a mass that we don't know. And we want to know what's the force between the Sun and this mass. Well, we know the force is 470 newtons. So what's the mass? How much do we have? And that's what we're going to look at, going to calculate first. So let's go look at the calculation. So what we're going to do, we need a mass of 2. This we know, this we know, this we know, this we know. Remember, this is 470. That's the force. That's the gravitational force that we're seeing. G is that constant. And it is a small number. It's 10 something times 10 to the 11th. And let me look that up quickly. You'll get this on your test. And honestly, guys, you probably know how to do this already. Let's see. G is 6.673. Times 10 to the minus 11th. And we got all those units that we're not going to worry about at the moment. Mass of 1 is going to be that 2.0 times 10 to the 30th, and that's in kilograms. And R is in meters, and what we have, let me come back up here, 7 times 10 to the 5th, kilometers. But all these, this unit is newtons, kilogram squared over, meter squared over kilogram squared. So we need the numbers in meters, not kilometers. So we need to multiply this by 1,000. And if you change that back to scientific notation, that's going to be 10 to the 8th meters. So that's the numbers we're looking at. So we have, what we need is mass 2. So let's go ahead and rearrange the equation. I like doing this algebraically first, using the variables before putting the numbers in, because I like to save space. So if you want to put the numbers in first and then isolate the unknown, that's fine. Oh, excuse me. So let's multiply everything by r squared. So we have r squared times f of g, and that's equal, so we got g times m1 times m2. And so we got the r, move the r squared over. Now we need to take these two and divide each side by g and m, g and m1. Delete. Oh, so r squared times the force divided by gravity times m1. Excuse me, should give me mass of 2. So let's go, I'm going to move this to the next slide. I got another empty space. So r squared is, r is 7.0 times 10 to the 8th. And we're going to square that. Times force, remember, is 470. And then we're going to divide, and we're going to take g, which is a 6.673, times 10 to the 11th. Now, minus 11th. Now, folks, one thing I want you guys to remember is that when you do this calculation, if you're doing it on your calculators and you do not use the exponent key, you write this out, you need to put this in parentheses and actually put a double parenthesis. So parenthesis, this in parentheses times the mass, 2.0 times 10 to the 30th, also in parentheses, and close the parentheses. Because if you don't, you're going to end up with the wrong answer. And many times I see this with students who are struggling, and they know how to do the math, they know how to write it down on paper, but they have trouble working this into the calculator because the calculator is stupid. 7.0 raised to the 8th. Now let's go ahead and square that. And you should get 4.9 times 10 to the 17th. Then we're going to multiply that by 470. And the top number, so mass of 2 is equal to the top number, which is 2.303 times 10 to the 20th. And we're going to divide that by 6.673 to the negative 11th. And multiply by 2.0 raised to the 30th. Whoops. Make sure you hit the right key. And I got 1.3346 times 10 to the 20th. And so we're going to get a nice easy number if you do all the calculations correctly. So 2.303 raised to the 20th divided by 1.3346 raised to the 20th. And I get a mass of 1.73 kilograms. And that is the answer I am looking for. Have a nice day, guys.